Okay, now, anytime we have a repeated factor, basically what you do is start with 1 and work your way up to that power. So, if I had x minus 1 cubed, I would need 3.
X minus 1, x minus 1 squared, x minus 1 cubed.
Very good. To the first power, to the second power, and to the third power. Okay? So when we have repeated powers, that's how we have to break it up to do our partial fraction decomposition. Okay. So, let's go back to our current problem. Now, when I'm deciding what to multiply by, I have to get back to this denominator. Right now, I have an x squared plus 1. So basically, this fraction has to be multiplied by an x squared plus 1. And an x squared plus 1, so that we have the same denominator. So, the a plus b gets multiplied times the x squared plus 1, which makes a x cubed, which is where some of you stopped, plus ax plus b x squared plus b. Okay? Now, this fraction was already over the common denominator. It gets multiplied by nothing. So we have, okay? Now, if I had written this out at the front of this numerator, would you have known what to do? Yeah. There is no cube term. So when we start putting them together, we automatically know A is 0. Okay? Now we'll put our square terms together. Oh, that's it. So now we know that B equals 3.
I like how that works out sometimes.
Okay. Now let's put the linear terms together. Okay, so now we know that 2 equals a plus c, but we know a is 0, so c is 2. Okay? And finally, let's do our constants, d and a b. So we know that b plus d equals 2, but we know that b is 2, so
D 0.
d is 0. All right.
Why is
so
D
now,
equal to 2?
Yeah, the excuse is
because
B should be equal to 3, shouldn't it?
Yeah, because it's 3.
b is equal to 3. Oh, it got erased.
Oh.
I drew 3 and then I erased it. Okay, so b is 3.
A is 0. D is
So then d
-1.
is -1.
there we go.
All right, now we're straight.
Now we're cooking.
Okay. So the partial fraction decomposition of this original fraction. Rational expression. All right, so a is 0, it goes away, I just need a b. So I have 3 over an x squared plus 1. And then c is 2, so I have a 2x, and a d is a -1 over 2x squared plus 1 quantity squared. Okay, yes.
When would you have it where it's just a? Like, what would the denominator look like for just to be a and then dx plus c?
Okay, so if your denominator is a linear first power, x minus a, then we could just have an a. If your denominator is an irreducible quadratic, x squared, something, I don't know, let's make something that doesn't work. An irreducible quadratic, that's when you need this. So if you have a quadratic that doesn't factor, that's when you need it. Okay? Colin?
Would you have taken off since I put 0x plus 3? Or should I just not put 0x?
We don't need that, but it actually ties in nicely to today's lesson. Because what would the horizontal asymptote for this be?
0.
0. And we'll talk about why that's kind of important in a minute. Okay. John?
I forgot how to do this yesterday, but like, how would you like break up like a number 8? How would you break up the denominator in the 3 points?
Okay. Number 8.
That's just the denominator.
X, because x squared is x times x. And you can figure out what that is.
Okay, so for number 8, our denominator factored to x squared times x plus 2. So when we break it up, this is a repeated factor. So we have to do x to the first, and x to the second, and then x plus 2. Those would be our 3.
Why is it?
Okay?
Why is the
This
middle-
can be over A, this can be over B, this can be over C. Because
Why can that be over B? Why can't it be over BX plus C squared?
it's not,
Yeah, like X squared, like the original.
it is factored.
Under BX.
It is factored. So it's woo. Nope, that's what.
Can we do that?
Oh, you're saying like the denominator is already factored?
Yeah. The only time we put it over
Sorry.
the ax plus b is if this is an irreducible quadratic. It doesn't factor. Yes, ma'am.
So like in number 7 and then number 23, both of them, like the denominator's the same. So in 23, do you also do ax plus b and then plus cx plus d?
Correct. And then what happens is your a ends up being 0, and your c ends up being 0.
But I got for d, I got 5 instead of 3.
Okay, we can look at it. All right, the other one I had worked out was 27. So that was one that did have the x squared. So we needed an x squared, and an x minus 3. Now, when you're multiplying here, this one's over 1x, but the common denominator has 2 of them. So we have to multiply by an x and an x minus 3. This one's over the x squared, so just the x minus 3. And this one's over the x minus 3, so just the x squared, which gives us this line.
That I did very.
Okay? So those are what the steps look like for 27.
I got it.
Here I have my
Oh my gosh,
A,
I got it right.
my B, and my C, and I plug in A, B, and C.
So you keep going so you fill it up like the x squared, and then you use the thing after that. So if it was x cubed, you keep go
You
c
need
would
an
be
x,
x
an
through,
x
and then
squared,
d.
and an x cubed.
So you would have a d.
You possibly could, yeah. All right, so you want to see 23? Yes, ma'am?
Just going back to 23, I only did the a plus b, like I didn't do the ax and all that, but I don't know doing just an a.
I think it's because there was no x term. So let's take a look at that. So we have 2x squared plus 5. And then our denominator is this. So to the first power, to the second power, alright, so this is good. It's already over the common denominator. This one needs to be multiplied by another. Okay, so this gives us ax cubed plus bx squared plus ax plus b. Okay, so we have 0 x cubes, we have 2 x squares, we have 0 x's, and we have a 5. So the cube, the square, the x's, and the constants. This is a c. Alright, so 0 equals a. 2 equals b. 0 equals a plus c. Oh, that was supposed to be blue. And then 5 equals b plus d.
I just did 5 equals d, I didn't do the
Gotcha. So if a is 0, c is 0 also. And then if b is 2, d is 3.
That means a mistake, and I didn't get the right answer.
So a and c were both 0. So we have 2 over x squared plus 1 plus 3 quantity over x squared plus 1 quantity squared. Okay? Alright. Alright, I'm about to teach the new lesson. I need everybody to pay attention to the entire thing and not have conversation between yourselves. Okay? Alright, today what we're looking at is the type of rational expression we have not looked at yet. Have you guys noticed in every single problem we've done so far, the degree of the numerator was less than the degree of the denominator? Okay? So we have the other two cases to study today, where the degrees are equivalent and where the degree of the numerator is greater than the degree of the denominator. Okay, so with an algebraic fraction, they are considered improper if the degree of the numerator is greater than or equal to the degree of the denominator.
Oh my gosh. Rats.
So, to work these problems, we can't have that. Our partial fraction decomposition will not work until we correct that issue. So, what could I do to correct the issue?
You could.
We could factor it if something canceled, that'd be helpful. If it doesn't, what could we do? Alright? Divide. Yeah. Divide. Okay, so that's how we're going to correct the situation in the first one. Example 1 is where the degrees are equivalent. So we're going to divide. Okay? And we want to use long division.
Always?
I don't know how to do that.
Definitely in this case, because my denominator is not a linear divisor with a leading coefficient of 1.
That's true.
Alright, so what did we multiply x squared by?
2.
Okay, we do. 2.
That's it.
Alright, so we get 2x squared minus
8.
8? Okay,
Do you actually have to do something with the remainder here?
so we're going to, yes.
That's unfortunate.
Alright, so here we get negative 6. So this is equal to 2 plus negative 6 over x squared minus 4. Okay.
Why did you bring the X over?
Alright, this is the remainder. Don't we always write? Oh, I forgot the x. You are right.
That's what I was like.
So when we subtract here, we do end up with x minus 6.
Wait,
You
why is
guys
that?
are right. I was wrong. X minus 6.
Oh.
And why did you put the 2 there? Because that's what you multiplied it by?
Yeah.
And no, it's all.
Okay. So division is always our quotient with our remainder, right? Over our divisor. So this breaks down into this. What do you think the 2 represents? Oh, we could give it a letter. Okay, let me be more specific. What do you think the 2 represents in terms of its graph?
The y-intercept.
Dang it.
Absolutely
I
not.
was actually thinking that. Why is that?
Slant asymptote.
Horizontal asymptote.
Why would?
Horizontal asymptote.
Oh.
Okay.
Because if you divide by
Every
3,
single other one that we've studied had a horizontal asymptote of what? 0.
Oh, it's good.
Could I have added 0 in front of all the other stuff we did?
Yeah.
It's just
Yeah.
a fancier way of
Possibly.
So
dividing.
this is representing our horizontal asymptote, which tells us about the end behavior of the function. Okay? So that's what this is telling us about. It's telling us about the horizontal asymptote, which, guys, can we cross a horizontal asymptote?
Yes.
Yes.
Only in the middle. Not
Okay,
in the middle.
not at
between,
the
not
end.
between.
Not between, okay? Not at the ends. Okay, can we cross a vertical asymptote?
Yes.
Yeah. No.
No.
That's what
No.
I was
No.
Why would you say that?
All right.
Or slant. You can cross
Okay.
slants.
Can't you in the middle?
Well, what happens with a vertical asymptote is a vertical asymptote represents an undefined value for x. A value for which you can never plug into the function. And because you can never plug it into the function, Can we go across it? Now, could we cross it in terms of a hole? Yes, and then it's not an asymptote, it is a hole. So, alright, now, so what we have here, this 2 is telling us about the horizontal asymptote, which, in terms of rational functions, that horizontal asymptote helps us with the end behavior. Okay, now, this looks like what we've been doing.
It does.
After we do the division, then we can break down any remaining fractions.
So we just leave it to
Okay? So, yes, and the 2 stays out in front. That's exactly. So the 2 stays here. Now you got to work with this part. Okay? So everybody work with that part. And I'm going to go and individually answer the questions as I put the video on pause. Okay. So let's take a look at one that is improper, but our fraction, our denominator we don't need to do anything with it. It's just improper.
Okay.
We can't write this as 2 fractions because look at this denominator. Does that denominator factor in any way, shape, or form? No. So really, all you would do on this one is just divide, right?
Right. 3x squared
Plus 2x. Okay, so when we divide here, on this particular problem, what do you multiply x by to get 3x squared?
3x.
3x.
Plus 3x.
Okay, so then we have to change our signs, right?
This stuff is too complicated.
And then we get negative x. And what do you multiply x by to get negative x?
Negative 1.
Negative 1.
Wow.
And so then we get negative x minus 1. And then we change our signs. And we get
X is
1.
I mean, just 1. My bad. Forget X.
So x or 1 over x plus 1.
So, guys, what is that on the graph?
Slant
Ah, it is.
Oh, it's a slant
It
asymptote.
is. It is.
This makes sense.
Okay, so see how what we're doing now ties into what we just did?
Yeah.
Okay, so this gives us a slant. Now, here comes the doozy.
The graph.
Oh,
But it's not a
doozies.
doozy for you guys, because you're ready. You're ready. It's going to look ugly, and then you're going to go, ah, piece of cake.
I really
Wait,
like
what is, oh, I was just about to ask that.
Alright, so here comes example 3.
Do it on my
So, no, I'm going to help you. I'm going to help walk you through this one. So, we have a quartic polynomial in the numerator and a quadratic in the denominator.
Wait.
Okay? But the degree of the numerator obviously is larger because it's a quartic. So when the degree of the numerator is larger, what do we do first?
You do the division.
You do the division. Alright, so we're going to do the division and you're going to get excited about the actual type of asymptote.
So anytime the numerator is
Yeah,
equal
that's
to or
cool.
greater than you divide.
That's
Basically. That's all we're
To the asymptote,
The asymptote is always at y equals 0 when the numerator is smaller.
I feel like the
Because
asymptote
when we
is
divide, we get a 0.
is it no asymptote?
No, it's a fun asymptote. Let's do it.
It should be a parabola, right?
It is.
Cool, wow.
It's gonna be pretty much multiplied by it.
Why don't
No, it's you multiply the thing by the thing.
Alright, so we have our x squared,
Yeah.
x to the 4th, plus
2x
2x
squared.
cubed
2x cubed.
minus
Oh my goodness.
3x2.
3x to the 2nd. Alright.
So minus change.
Okay, then what do?
Change signs.
We change our signs.
X squared. Those both cancel. That's nice.
Oh wow, that's very pretty.
What's nice?
And then you are ended up with an x squared.
Okay, so now we got an x squared plus a 4x minus a 1. So what do we multiply by?
Negative.
Wait.
No, just 1.
Just 1. So that gives us an x squared plus 2x minus 3. Now what do?
Change signs.
Change signs.
Change signs.
Cancel.
So this gives me 2x plus 2.
Yep.
Alright,
Is that a remainder?
so that is our remainder.
Because there's
So
not-
what we're working with right now is an x squared plus 1 plus a 2x plus 2 over the divisor. x squared plus 2x minus 3.
So we ignore
Okay,
that.
so what is this part? That's that parabolic asymptote.
Asymptote.
Pretty cool.
So,
And then this part, we
Oh,
can
you
break
took
it down further.
Over the denominator.
Well, we get
Okay.
points off if we put the x squared plus 1 in parentheses.
You can back to the
For
ball.
grouping the methods.
It's not wrong.
Okay.
Alright, so now this, we can break down further. Alright, because this breaks down into x plus 1, no.
X plus-
X minus 1, x plus 3.
Yeah.
Okay, so we got linear terms here, so I just need an A and a B, right?
so good. A and a B. That is correct.
Okay, so the A gets multiplied by the x plus 3, so it makes AX plus 3A. The B gets multiplied by this, so it makes a BX
Plus three.
minus B.
Fine.
And that's equal to 2x plus 2. So 2 equals A plus B. And 2 equals 3A minus B. So 4, A equals 4. A is 1. So B is 1.
Yeah. Shield.
Yeah, I know.
Alright, so the complete partial fraction decomposition is the x squared plus 1 plus 1 over x minus 1,
Oh, wow.
and then 1 over x plus 3.
Boy, Largo.
Wait, mine are mixed up, is that okay?
That's fine.
So
It's
my-
okay if these two are in a different order, as long as you have the right numerators. Now this one's easy because they're the same, so it really doesn't matter.
Yeah.
But there she is. Okay, so tonight's homework. The first problem is a review from last night. If you look at it, the numerator, the degree of the numerator is less than the degree of the denominator. So where's the horizontal asymptote? Y equals 0. So we don't have to divide. But it does have a repeated factor. A repeated factor. So you got one more practice with repeated factors. And then the next two are equivalent in degree. And the last two, the numerator is greater than the denominator. So you got a little bit of everything.
That sounds good.
It's the
Yeah.
right?